So today we're going to start off talking about solutions. We're just going to discuss real quick what a solution is and the different types of it. What we want to be able to do at the end is just be able to differentiate between different solution types based on the amount of solute present in this actual solution. So starting off, a solution is nothing but a homogeneous mixture, so it's very evenly distributed, of a solute and a solvent. The solute is a substance where there is a lesser amount of it, and the solvent is a substance in which there is a greater amount of it. Now, solutions come in three different types. You have the unsaturated solution, the saturated, and the supersaturated solution. An unsaturated solution is one that contains less solute than a saturated solution. So a saturated solution, what that is, it's a solution in which the maximum amount of solute has been dissolved for a given solvent at a constant temperature and pressure. Basically, solvents can each dissolve a different quantity of solute particles, depending on what the identity of the solvent is. When you have reached the maximum amount of solute particles that could be dissolved, you get what's called a saturated solution. So if you have dissolved less than what the solvent can hold, you're unsaturated. Now, a supersaturated solution is one that's actually able to contain more solute than the maximum for a given temperature. So when you reach your max, and you can actually dissolve more by playing around with the temperature, and when you are able to dissolve more solute than what the solvent can actually dissolve, you get what's called a supersaturated solution. Some examples of those are like heating packs, where you have to go and actually break up the pack. Doing that disturbs the equilibrium within the solution, and you get heat being produced. That's a supersaturated solution. Once the solution recognizes that there's actually more solute dissolved than there's supposed to be, then it starts to change, and those solute particles that were dissolved start reforming and recrystallizing. That whole process in the heating packs actually produce heat. So when we talk about the solutions, we have to talk about solubility. Solubility is the amount of solute that can actually dissolve in a given quantity of a solvent at a specific temperature or pressure. Basically, this is a measure of how much solute you can dissolve based on how much solvent is present at a temperature and pressure. Now, factors that affect solubility: surface area. If you increase the surface area of the solute, you are able to make more particles of the solute come into contact with the solvent, so it's going to help with the rate of dissolving. Stirring it, so the more you're stirring a solution, the more you actually get it to dissolve, because again, you are increasing the contact between the solvent and the solute. And temperature, you are increasing the kinetic energy of the molecules and the particles. And so you're actually going to help speed up the process in which the solvent molecules are breaking down and surrounding the solute particles. Okay, so surface area, stirring, and temperature are all different ways to affect the solubility of a solution. Now, this is called a solubility curve. A solubility curve, it's just basically a graph of a substance, the solvent, of the solute, and it keeps track of how much of the solute can be dissolved in a specific solvent at a given temperature. So the solubility curve is for different substances and their ability to dissolve in water. So it just kind of keep tracks of different substances, as you can see from the label, and exactly what amount of them can be dissolved in water at a given temperature. So let's take a look at how we actually would use this. So we want to know what type of solution is made that contains 20 grams of salt at 70 degrees centigrade. So we want to know, are we going to have an unsaturated, saturated, or supersaturated solution if I have dissolved 20 grams of salt in water at 70 degrees? So we want to find the solubility curve for salt. Here it is, NaCl. So at 70 degrees, we can dissolve approximately 35 grams of water. So at 70 degrees, 35 grams of salt would make that a saturated solution. If we have dissolved 20 grams is below the maximum quantity, making this an unsaturated solution because we have dissolved less than the maximum. So if we have dissolved the maximum, then that would have been a saturated, and if we had managed to dissolve more than the maximum, it would be supersaturated. Now, just one last thing talking about solubility. For temperature, the solubility of a solid will increase as the temperatures increase. So the more heat we add to a solution, the more solids we can dissolve into it. However, for gases, it's the exact opposite. The solubility of a gas will decrease with increasing temperature. If we go back and actually take a look at the solubility curve, you can see that as the temperature is increasing, all of these curves are showing an increase in the solubility, except for one. This line right here for SO2 shows a decrease. So as the temperature is increasing, we're actually dissolving less and less of this SO2 substance. That tells me this one is a gas and all the other ones are solid. And this again has to do with the kinetic energy of the particles. When particles are getting dissolved in water, gas molecules, which are very, very high in kinetic energy, by adding even more energy to them, it's going to be a lot more difficult to trap them within the solvent particles. So that's why the solubility of a gas will decrease as the temperature increases. You can think of that as like your soda going flat. When you leave it out sitting for too long, the carbon dioxide in the soda eventually goes away because it's getting warmer. So it's a lot harder for it to remain dissolved in your soda. And then for pressure, by increasing the pressure, they actually have very, very little effect on solids and liquids in terms of the solubility of it because the particles are already so compact. Increasing the pressure is not really going to make much of a difference. But for gases, if you increase the pressure, you can actually dissolve more gases in a solvent because now, even though they're very high in kinetic energy, increasing the pressure is actually kind of like forcing it to be in there. That's how they make soda. They actually just go and use really, really high pressure to dissolve the gases within the liquid.